Hey, welcome back. This video is going to cover chapter 8.1, which is continuing on the topic of similarity. So in exercises 1 and 2, the polygons are similar. We want to find the value of x, right? So there's a side length that is missing. We want to figure out how long that side is. All right, so remember that similar figures have the same overall shape, but different sizes. And so we would like to know what is the scale factor, right, between the two figures, right? Is one figure 2 times bigger than the other? Is it 1.5 times bigger than the other? Is it half as small as the other, right? So we need to first find the scale factor, and that usually is the key to unlocking all of these problems or questions. Right. So in question 1, the two rectangles here have different orientations. So what I'll do is I'll redraw the smaller one so that it's kind of oriented in the same way as the bigger one. Okay, so this side would be 2 and this side would be x. All right, so now what I got to do is I got to figure out, well, how much smaller is this rectangle compared to the other one? Okay. I want to figure out what is the scale factor, okay, between these two rectangles. Okay. An easy way to find the scale factor, right, is to find a pair of corresponding measurements. So for instance, we have the two top measurements of the rectangle, right, and then we just create a ratio, right? Take the new measurement or the final measurement divided by the old one, right? So this we want it to be 2. We're starting at 3, so we're going to say 2/3, 2/3. Okay. So this small rectangle is 2/3 the size of the big rectangle, right? Just by taking that ratio 2/3. So now that I know the scale factor, right, we can apply it to any of the other measurements. Okay. So let's just confirm though. Okay. So if I take the top measurement and I multiply it by the scale factor 2/3, okay, I end up with the next measurement too. Okay. So we'll do that to the side measurement. We'll start with 7. We'll multiply it by the scale factor 2/3. And what we get, of course, is a decimal 4.666, which is 4 2/3. So x is going to equal 7 times the scale factor 2/3, which is 14/3, which is approximately 4.67. Question 2, we have some triangles. Again, they're kind of rotated differently, so I'm going to take the smaller triangle, rotate it so that it has the same orientation as the bigger triangle. Okay, so this is 8 there. This one would be x, and this one would be 12. Okay, so I just did a 180-degree rotation of this. All right. So let's find the scale factor from the big triangle down to the small one. Okay. So what we have to do is we have to find a pair of corresponding measurements. Okay. We could use the bottom measurement here. Okay. So we're starting with a length of 20, and we're reducing down to a length of 8. Okay. So the scale factor would be 8/20, and we can simplify that as well. Let's see, they're both divisible by 4, so that's 2/5. Okay. So this triangle is 2/5 the size of the bigger one. Okay, our scale factor is 2/5. Okay. All right. So now that we know the scale factor, we can apply it to any of the original measurements. Okay. So just to confirm, if I take 20 and multiply it by 2/5, I get 8, which I should. Okay. So I can take 25, multiply it by 2/5, and that should give me the new measurement of this left side here, which is 10. So x, let's write it over here. X is going to be the original length, 25, times a scale factor, 2/5, which is just 10. All right. Let's pause the video here, and then I'll make a separate video for the remaining problem.